These are the two most powerful types of nuclear weapons currently in existence. A thermonuclear bomb, H-bomb, is considered to be more powerful but less common than an atomic bomb, A-bomb. Atomic bomb. An atomic bomb operates on the principle of breaking apart heavy, unstable atomic nuclei like uranium or plutonium into lighter nuclei, releasing energy in the process. The detonation process of an atomic bomb occurs through a chain reaction, starting when a neutron, a neutral subatomic particle within an atomic nucleus, collides with a uranium or plutonium nucleus, causing it to split into more stable elements, usually barium and krypton. This process releases energy in the form of heat, gamma radiation, and some neutrons. These neutrons then go on to repeat the same process until the reaction fuel is depleted. This chain reaction occurs within a very short period, on the order of microseconds. The explosive power of an atomic bomb is typically measured in kilotons, KT, equivalent to thousands of tons of TNT explosives. Each type of atomic bomb fuel has a characteristic mass known as the critical mass. If the amount of fuel is less than this critical mass, the chain reaction does not occur. The reaction fuel in each bomb is divided into subcritical portions to ensure safety. To initiate a detonation, these separate portions are brought together. The critical mass of pure uranium-235, for example, is 50 kilograms. To date, the United States is the only country to have used atomic bombs in warfare. The first atomic bomb dropped by the United States on the city of Hiroshima on August 6, 1945, had an estimated explosive power of around 15 kT. The second bomb dropped on Nagasaki 3 days later had an estimated explosive power of around 20 kT. These bombings were part of the Manhattan Project, the U.S. research program on nuclear weapons during World War II. Thermonuclear bomb. Initiated by the United States in the early 1950s, a thermonuclear bomb is believed to have explosive power thousands of times greater than an atomic bomb. The fundamental difference between the two types is that a thermonuclear bomb releases energy from the fusion process of two light nuclei, hydrogen, into a heavier nucleus, helium. This is also the reaction occurring on the Sun. However, since all nuclei have positive charges and repel each other, a tremendous amount of energy or very high temperatures are required to bring them close enough for nuclear fusion to occur. This condition can only be achieved by detonating an atomic bomb. Thus, a thermonuclear bomb is a dual-stage bomb. First, an atomic bomb must be detonated to create the conditions for the thermonuclear reaction to take place. How destructive is a thermonuclear bomb? The energy released from a thermonuclear explosion can instantaneously destroy everything within a radius of several kilometers. The immense heat can generate firestorms, and the high-intensity white light from the explosion can cause temporary blindness. Radioactive fallout and byproducts of the reaction, such as cesium-137 and strontium-90, can contaminate living organisms, pollute the air, soil, and water for hundreds of years. Current technology allows for the creation of thermonuclear warheads small enough to be mounted on ballistic missiles or artillery shells. A thermonuclear bomb has explosive power thousands of times greater than a regular atomic bomb. According to military experts, an atomic bomb's explosive power is measured in kilotons. 1 kiloton equals 1,000 tons of TNT explosives. Meanwhile, the yield, explosive energy, of a typical thermonuclear bomb is measured in megatons, equivalent to millions of tons of TNT explosives. In history, the first air-dropped thermonuclear bomb, Ivy Mike, tested by the United States in 1952, had an explosive power of 10.4 megatons, creating an impact radius of 56 kilometers. In contrast, the Fat Man bomb that killed 40,000 people in Nagasaki had an explosive yield of only about 21 kilotons. What sets apart North Korea's bomb? However, one notable point in North Korea's announcement is their claimed successful test of a miniaturized H-bomb. If true, the situation becomes even more serious. Why is that? The technique of miniaturization has been applied to nuclear weapons for decades to fit nuclear warheads onto long-range missiles. And if nuclear warheads are replaced with thermonuclear bombs, it means that even countries with tremendous military capabilities are being threatened. Currently, there are 9 countries that have declared possessing nuclear weapons, including the United States, the United Kingdom, France, Russia, China, India, Pakistan, and North Korea. Among them, only the United States, the United Kingdom, France, Russia, and China have thermonuclear bombs. North Korea recently claimed to have a thermonuclear bomb, but there is no specific evidence yet. Iran and Syria have been accused by the United States of possessing nuclear weapons. Concerns about the risk of nuclear war led to the widespread adoption of the Treaty on the Non-Proliferation of Nuclear Weapons, NPT, since 1968, aimed at preventing the widespread proliferation and possession of such weapons, while promoting the peaceful use of nuclear technology. Currently, 190 countries have participated in the NPT,